Hi, welcome to Functional Just in episode 11. A few people have been asking me when I'm going to do a video about ZIO, so I thought I'd do a video about ZIO this week. And what I'm going to do is show you a program I've written in ZIO that does something you might describe as real world, solves a real problem. We're not going to talk about ZIO from a theoretical point of view or category theory or anything like that. And I'm not going to write any code. I'm just going to give you a tour of a program and talk about all of the pieces that went into making it. This program has a long history, so I did a blog about this in 2017 where I implemented the Hacker News API to demonstrate a library called Fetch, which is a purely functional library that uses effect systems to fetch URLs from remote sources, and then I hooked that up to the Hacker News API and then added this visualization so you can see this concurrent thing going on. Pulling a bunch of web requests. In this case, you can see that it pulled 8 at a time in 4 parallel operations. So I was already interested in using the Hacker News API as a way to show how to write concurrent programs. And then a couple of years ago, in April 2019, I did a blog post using, again, the Hacker News API using ZIO. So this was before ZIO was version 1.0, so this was release candidate 8 of ZIO. So I wrote a program that pulls the Hacker News information, displays it at the console, and an introduction to fibers, scheduling. So I'll definitely put a link to that one in the notes. So what I'm going to do today is just give a tour of the program. I've updated it, I've used some more modern libraries, I've used the latest version of ZIO, and we'll see what Z-layers are all about. They're new since I wrote this blog post. We'll see what ZIO Magic is all about, which is very new, and we'll see how you can use the ZIO JSON library to parse data that we get over the wire. So one of the libraries I'm using that I wasn't using before is STTP. So this is a really good library from the software mill. It's open source. It's basically an abstraction layer over HTTP requests, and the nice thing about it is you can plug in lots of different backends to do the actual requests, and it also interfaces with various libraries. So you can use FS2, for example, or you can use ZIO. You can use HTTP4S. You can use Twitter Futures. So it's very flexible. It lets you write your code that does HTTP requests just once, and then makes it easy to test them, and it makes it easy to migrate them into different systems. The other thing we'll look at is the ZIO library itself. So I'm not going to spend too long introducing ZIO because it's been done many times before and really well. But just the very basics are that ZIO is a library for asynchronous concurrent program. It gives you all the benefits of Typesafe functional programming. And essentially it's built around this effect. So if you're not familiar with ZIO at all, you can think of ZIO as being a superpowered future that lets you do asynchronous operations. And ZIO has 3 type parameters. It has, in contrast to Future, which just has the one, ZIO has the R parameter, which is the environment. So that gives you a way to pass in useful features for your program to use, sort of like dependency injection. Then it has a separate channel for errors, and then it has the success type, which is A. So on top of ZIO is a bunch of other stuff. So ZIO includes a very sophisticated runtime system. It includes something called fibers, which is a lightweight threading system. So you can have thousands of fibers running where you wouldn't be able to have thousands of threads. And there's a huge ecosystem of libraries and tools built around ZIO, and it's really growing in popularity. Has a huge welcoming community, so I'll definitely link to that. The last thing, I'll talk about this a bit more when we get to Z-layers, but I'm using ZIO Magic a bit in this program. ZIO Magic is a library which makes using Z-layers much easier, and using Z-layers is a little bit tricky. ZIO Magic is literally a magic library that helps with that. So what's the Hacker News API? Hacker News is a news aggregate website. It has a bunch of stories on it that people share and upvote. And each story can have a comment. You can have a hierarchy of comments. And the API exposes all that. So if you wanted to use it to mine data, see if somebody's talking about your company, something like that, you can go ahead and use it. And the API is very simple. It just gives you a HTTP REST interface to query the site and get the data back in JSON format. So for example, if you want to get the front page, what you have to do is call the top stories endpoint, and that just gives you this list of item IDs. So this is a huge list. This is sort of the top 400 or 500 items, and if you were to just take the top 30, that would be the front page. And then what you need to do is take each of these item IDs and do an item request, and that will give you information on that item. So that's going to give you the direct comments on that article, the score, how many upvotes it has, who posted it. It's going to give you the title and the URL. So the program we're going to look at is actually going to get the front page of Hacker News, and then it's going to query all the items, and then it's going to be able to search for keyword. So that's an example of a useful thing that you might want to do. So let's take a look at the code. So the code is on GitHub, and I'll certainly link it below the video. So let's take a look at some of the pieces. So this is the build file, the build SBT, and what we've got in here is, first of all, we're going to bring in the ZIO dependencies. So we're using ZIO itself, that's the core library. Then we're using ZIO test, which is obviously a testing library. ZIO test SBT, which makes it easy to run ZIO test from the SBT tool. And ZIO streams, which is obviously the ZIO streaming library. Then we bring in ZIO Magic, and we'll see why later. We've got two STTP libraries. So one is the core library, and the other one is the component that lets us use STTP with ZIO. ZIO JSON, we're pulling that in. So ZIO JSON is quite a new library, but it's very easy to use and quite performant, and a nice way to parse JSON. This thing, nice dates, is a Java library that I use just to give us nice looking dates. This is the thing that tells you that a news article was a few seconds ago rather than me having to calculate it, and just gives us a better display. And then I'm pulling in Ammonite, which is a great library from Lee Hao Yi, which lets you run a REPL, and I find that's a nice way to test my program. So the first thing we need to do is represent the data. The way I represent the data is just using a sealed hierarchy, and at the root of that is a sealed trait called HN data. So everything that I pull from the endpoint, I'm going to pass it into a HN data item. So HN user represents a Hacker News user, so you can match the ID in the stories to a particular user, and then you can grab this information. And this will give you information like when the user account was created, how much karma they have, the optional about description, and a list of all the submissions that they've made to the site. Now, in order to actually retrieve information and pass it, we need to help ZIO JSON out. So we can just use this syntax. We can automatically derive a JSON decoder so that when we get the JSON data, we can go ahead and pass it using this, as long as we have this implicit JSON decoder in scope. The main item we'll be looking at today is HN item. So everything on the Hacker News page is an item. This includes comments, stories, job posts, and polls. They all fit into this same structure. And of course we have a derived JSON decoder for that one too. Now this one's slightly more complex. Some endpoints return a list of item IDs like the top stories, and that doesn't really map to a case class. So instead what we're doing is creating a case class that wraps a list of item IDs. So that means that our decoder has to use the map function. So what you can do is when this list of things comes in, we can map it, and we can just say, I want you to put it inside this list. So what this map function does is, instead of giving you an auto driver, this gives you a way to add in manual instructions or a manual function to show how to decode the JSON into your particular type class. So that's the data model. The next thing we should look at is the client. So the client code is what I use to actually do the request to the server. So let's take a look. So all I've done is added functions to an object. So there's no initialization needed for the client. The STTP library will take care of anything that needs to be initialized as part of the Z layer system, and we'll see how that works when we get to the main program. And then we set up some basic data that we need to do the request, so where it's going and what the headers are. And then we've got some functions to build the endpoints. So when you do a user ID, we just need to build the endpoint that starts with the base URL and then adds the actual query to get the right thing. So with STTP, you build queries before you execute them, and so that's what we're doing here. So when we create a request, it takes some type, which is going to be a HN data type, so it could be any of the types that we were talking about there. We're going to pass in the URI endpoint that we're going to generate with one of these functions. And although it's not used in this program, we also pass in the last modified string that we got last time. And that's something that relates to caching. So we can add that to the header when we make the query. And then some APIs will actually use that and tell you if something hasn't been modified, so you can just use a cached version of it. So then we call basic request, which is going to actually do the request and return the response. So we give it the URI, we give it the headers, and then what we get back is either an error or we get a body. The body itself is just the string of the actual HTTP response, and then we can call the decode JSON on it to get the actual HN item. Note that this is polymorphic, so whatever type it is, it will call the correct decoder. The decoder is passed in here implicitly. So that's how our basic request system works. Then we have this get object function, which is a bit more low level. And you can see here that this might be a good time to talk about Z layers. So you can see that the return type of this is a ZIO because it's an effect. And it takes the R argument here, which is the environment. You can think of this as the dependency injection. It includes three things. So it's got the STTP client, which gives us the instructions, gives us the facility we need to make requests. It has a console, which we can use to print out messages to the console. And it includes a clock, which is used for anything that requires the time. Then you've got the error channel. So the error channel for this function is throwable. So this could either be throwable, or you could have, sometimes you have no error, so you can specify nothing there. Sometimes you might want to put your application specific errors in there so that you know that you only handle things that you specify. Then the final thing is the success type, which is our type parameter t, which type t is a it's a subtype of HN data. So then the program will work by calling the STTP function to send the request, and that will return us either a type T or an error, and then we can do some error handling, and then we can return the successful data. So let's take a look at an actual endpoint. So all of the endpoints will just take one line of code. So get the top stories, we call get object, we pass in the URL, and then we get, what we'll get out is the HN data that we're expecting for that endpoint, or we'll get an error, which in this case would be a throwable. Alright, let's take a look at the program itself. So here's a program called search top items 2. So I called it that because there's two versions of it. One of them is rate limited and one of them is not. This is the rate limited version. So I'll just give a quick walkthrough of what this program does. So the main program, the entry point to the program, to a ZIO program that uses app. So here we're using ZIO app to structure a program, which basically puts in a lot of the plumbing so that all you need to do is implement the run function, and you can build your program which consists of a single ZIO effect. So in our case, what we're going to do is call this ZIO when, which is going to say when the argument list is not empty. In other words, the user passed in a search string for us, then call the program with the first string that they passed. So let's give it a quick demo of what the program actually does. Alright, so I'm going to run the program, and then we can put in some search string. So let's see if there's any news about the sewers. Nope, there's nothing about sewers. That's probably good. Let's look at something we probably will get a lot of hits, because it searches the URLs as well as the titles and the comments. There you go. So you can see there's a lot of stories matching, and the match is in the URL. So let's do another search just for Apple, see what stories we have about Apple. There we go, we have one story about Apple. So you can see that we received 500 stories, so that's the list of 500 IDs. Then we took the top 30, and then we actually did 30 web requests to get the individual stories. So now we get to Z layers again. Our actual program here that we call with the search string is composed of a call to app, which is going to do some more work, and we also provide a layer here. So what we're doing here is providing the rate limiter layer. So what's the rate limiter layer? Well, it consists of all the things that we need to run the program. So we've got the clock again, we've got our rate limiter, which I'll get to. The rate limiter has some configuration. So to plug in the configuration, we use a different symbol. We use this one, which says I'm going to plug this configuration into this Z layer. And the other way to compose layers is the ++, which joins them all together. This is the actual config layer. So the only thing we need to config about the rate limiter is the time for the rate limit, which is 50 milliseconds in this case. And what that means is that when we run our program, we're going to be doing a maximum of one request in every 50 millisecond period. So here's the main program. The main program is, again, it's a ZIO effect, and you can see here that we specify the things it needs: a rate limiter, an STTP client, a console, and a clock. And it has no return value, so it's just a unit, and the error type is throwable. So the first thing we do is print out the message that we're fetching stories, and then we call the client getTopStories function. So what this should return is the list of IDs there. Then if the stories list is greater than 0, that means we can go ahead and get each of the stories. In fact, we're only going to get 30 of them. So front page size is just a config number here. We're going to take 30 stories, and then we're going to call for each, which in ZIO means give me an effect which is going to run for every member of this collection. So in our case, our list of 30 IDs. Now you can see that we're calling rate limiter delay here. So rate limiter is some code I've written to slow the request down, and the rate limiter is written as a layer, as we saw down here. And the delay function is all we need to do if we want to rate limit a particular effect. So what we're doing is we're saying delay this to ensure that the rate limit is not broken, and then do the following effect. And if you're not familiar with this symbol here, this is essentially a flat map. Sometimes you do a flat map, which flat map connects two effects together, but sometimes you don't care what the input value of this one is. So even though this has a return type, just unit, we don't want to do anything with it, so we use this instead of flat map. So this function, check out item for string, is doing all of the work of the program really. It has the search string, it has the item ID, and then what it's going to do is call client get item, and that will pull down the actual item information with the title of the story, the URL, and then we can just do a case insensitive match on all of the stuff that we're interested in. And if we do find something that matches, then we just print the item out. So just give another quick demo of how it works. So you can see that it's going quite quickly. If we wanted to, we could change the rate limiter config to be a bit slower, 10 times slower, and then you'll see that the program is actually going to take a little bit more time to work. So it's now taking half a second for each story, so it's going to take about 15 seconds to do the whole program. So when you're working with other people's external services, it's really nice to be able to limit things and be confident that you're not going to break their rate limits. So let's talk about ZIO Magic. So this is how we made the layers for our program without ZIO Magic. So you have to know what these symbols mean, you have to put them in the right place, and if you get it wrong, you're going to get an error that's not very nice to look at. With ZIO Magic, instead of provide layer, which we used, provide custom layer, you say provide magic layer. Then you just give it the list of all the things, and you really don't have to think about how they plug together. So if the dependencies are quite a complicated graph, you don't have to think about it, which symbol to use at each point. But not only that, if you get it wrong, it will give you a nice error message telling you what's missing. So ZIO Magic is using macros in the background, probably not literal magic, but it's a really nice tool, and highly recommend that you use it if you're using layers. So on the ZIO Magic webpage, you can see what some nested dependencies might look like, and how you can really simplify the way it works. And this is what the error looks like. So if you do make a mistake, you get this error. Now if you don't use ZIO Magic, then you'll get an error like this, which is, these kind of error messages are particularly hard to read in an IDE and debug them. So that's one of the reasons that I really like that ZIO Magic has come along. So the last couple things I want to talk about real quick are how the rate limiter works. So the rate limiter is written as a layer. What does it mean to be a layer? Well, I use something called the module pattern. So the module pattern implements a layer as a service. You can provide a service interface that looks like this, and this just has the single thing that we need to tell it is what is the type signature for our services methods. So in this case, as a delay function that creates a ZIO. And what we want to do is create a live implementation of this service that we can use in our program. But we also want to we also have the option to create debug versions and versions that we can use for mocking, so that you can test things more easily. So how does the rate limiter work? It consists of, as I mentioned before, it needs a rate limiter config, which is literally just going to give you the minimum interval between two events that are rate limited. So what I'm saying here is that the live implementation of this is a Z layer, which takes these following inputs, or it requires these input layers. It requires the clock, it requires a config. It is going to throw throwable, and what you get out of this is a rate limiter layer. So I can make programs that need a rate limiter, and then this is where they get it from. So this function from services M means that there's actually an effect that runs when I create the rate limiter. So the nice thing about Z layers is they can, when you create them, they can have effects. They can also use manage resources. So if, for example, you open a bunch of files or database connections, you can make sure that they're cleaned up when the Z layer is no longer used, and you don't have to expose that to the user of the program. So we've got a rate limiter config, we've got a clock, now we can go ahead and implement our delay function. So on the way into our delay function, we make a ref. So a ref is a purely functional implementation of a mutable variable. So refs are actually safe to access concurrently, so that means that this rate limiter will work with multiple fibers, and what we store in the ref is the next time that an effect can run. So when we start the process, the next time it can run is now minus the interval, and then when it actually rate limits something, it will decide how long it needs to wait for the next effect to run, and it will then add the minimum interval to that. Right. So you can read my notes if you want to understand this in more detail, but that's kind of how it works. And then we provide a shorthand way to access the delay function. So this is in fact what gives us the way to easily use this in a program in this simple way. And if you imported rate limiter here, you could just use delay directly. All right, the last thing I want to talk about is testing. So ZIO is great for testing. So there's a couple of different test suites in this program. One of them is to test that the client works. And the nice thing is we can test it without using the real Hacker News API. So I can create some sample expected responses, and then I can send those using this stub. So this stub is provided by STTP. So what you can do is you can make a STTP layer for mocking, which will look at each URI coming in, and if it matches a particular pattern, then you can return the exact response that you want to. So obviously this is what you need if you want to test without an internet connection and without the real API. And that's a really good example of how you can use Z layers. Different implementations of Z layers. One is to do testing, and one is your live implementation. So the second test suite is also important because this one shows how the fiber system enables you to do testing of concurrent programs. So if we use the test clock, which we're going to use by default in our tests, the test clock is like a mockable clock you might find in other languages. So you can create the test clock, you can set the time of it, and you can adjust the passage of time. So what I'm doing is to actually test the rate limiter, I needed to spawn multiple effects at different times to test race conditions and make sure that everything works. And so one nice way to do that I found was to create a queue of integers, and then when certain events in the program happen, I just add those events to a queue, and then when the program ends, I can check to see if the queue has the correct values. And the other part of it is to use sleeping, and fork. So what fork does is spawns something off on another fiber. So you can think of these first two lines as saying, whatever the rest of the program is doing, I want these two things to wait and then send a message to the queue, so that I know that in this case 1 second has passed, and in this case 1200 milliseconds has passed. And then I can adjust the passage of time, I can do my program things, and then at the end check to make sure that everything happened in the right order. So this is a rather clean way to test concurrent programs that rely on the passage of time, and I think that's a really outstanding feature of ZIO. So that's it. That's been a rather breathless introduction to where ZIO is today and how you can build a program. I'll include a bunch of links in the video notes to this, and hope you enjoyed the video. The next video is going to be back to coding. We're going to look at the reader T monad transformer and what we can use it for, and hope you enjoyed that. Thanks a lot. Bye bye.